Hello everyone. Now let's talk about experiments. So experiments is also a quantitative method, but then there are different kind of experiments. We will explore in details later on. So experimental method is actually a very old idea. It's from medical science and it's related to public health, and nowadays consider the coronavirus situation. I think it's even more relevant. So I think I'm going to introduce as much as possible. So if you are really interested in experimental methods, you need to dig deeper. So this old story is happened in the Song Dynasty, so which is about 11th century in ancient China. So the capital city back then had the contagious or infectious disease and the plague, and it caused thousands of deaths. Right. So now the virus doesn't discriminate anyone, right? Regardless you are the government leader or you are just an ordinary citizen, it doesn't matter, right? So the empire or the king wanted a solution immediately, of course, or as soon as possible, right? Otherwise, the disease is gonna kill more people, and definitely he wanted to save the capital city as well as people's life. So then a doctor proposed that the contaminated water could be the problem, right? But how he discovered that? So he randomly divided people into groups. So because there's the two water sources for ordinary use. One's the well water, the other used the river water as the other source of water. So then after a short period of observation, it discovered that if people continue using the well water, they got the disease, while people use other water sources, they didn't get anything. So water source from the well could be the problem, right? So you don't understand the medical mechanism, but you understand if you're drinking well water, you probably will get sick. So after identifying the well water was the cause of source, then he suggested to stop using the well water. But then you needed to decide what kind of medicine gonna cure these already sick people. So then you randomly assign those patients into several groups to decide which medicine actually worked the best, right? So generally speaking, you probably will have one group as your control group. Generally, the control group will get a placebo or nothing. Then group 1 get a certain amount of medicine. Group 2 get a different medicine or the same medicine, but with varied amount, right? To see what's the right amount for cure the disease. And the third group could use another one or different amount. Then until you find the right amount of the right medicine, then that can actually help people and get them back to health. All right, so this is the idea about experiment that saved hundreds of thousands of lives in the capital city in the Song Dynasty. So I think this is fascinating. Here I get the book. It's called Healthcare in 11th Century China. So this is where I get this story from. Right. So this is a really old idea, but in social science we didn't pay too much attention to experiments until recently, especially in public administration area. So I want to use an example to illustrate the usefulness of experiment. So this example is called the war between fat and sugar. So these things are tasty, but they could be bad for your health, right? So the question is sugar the toxic drug or fat the deadly ingredient? So the main purpose is to design a study, figure out which diet, low sugar or low fat, is healthier. So how would you design a survey to figure out which diet is healthier? Generally speaking, if you can recruit people, a large group of people, say 1,000 people, right? So then you randomly divide them into two groups. One will be your control. They have the low sugar or low carb diet. Now the other is your treatment group, has a low fat diet. Then after a month or two or several months, you measure a set of different health outcomes, like BMI, heart rate, etc., etc. Right? So figure out the difference between groups after a while. Okay, so then you'll understand which diet is actually healthier. So the key to the experiment is called randomization, right? So randomization, which means you are going to divide your participants into two groups. So we are talking about a very basic between subject design, all right? So one treatment group, one control group. So then we are testing the treatment effect, right, to see whether or not the treatment is actually working after a while. So this gives you the causality, ensure you the causality. Why? Because after randomization, you pick an average person from the control group and compared with that average person, compared with another average person from the treatment group, they should be similar to each other in terms of all the characteristics except the treatment, whether or not they got a treatment, right? Other characters, social demographics should be the same. Or, to be precisely, they should be statistically equivalent, which means there's no statistically significant difference between one average person from your control group and the other average person from your treatment group. They should be the same, all right? So, but however, is that practical? Say, okay, you recruit 1,000 participants and divide them randomly into two groups. Then ask one group, like 500 people, to stick with a low carb diet for a month, 2 months, or 3 months, while the other stick with the low fat for the same period. It may doable, but it will be very costly, as you can imagine, right? And that's probably not that practical unless you work with a large corporation or government funding. Otherwise, it's probably very difficult for an individual research to conduct a very large-scale experiment. But even if you can do so, we say, okay, pick one person, an average person from the control group. It should be statistically equivalent to the person from your treatment group. However, average people between groups are still not identical. There's a slightly difference between these two, right? We call statistically equivalent, which means there's no statistical significant difference between these two average person, but still there might be a slightly difference, right? So what can we do to ensure that these two persons, one in control, one in treatment, are totally identical? That's why researchers prefer identical twins. Because for identical twins, right, everything's the same, unless you put them one in control group, one in treatment group, right? So that would be the only difference. Now I happen to have this example. So as you can see, these two persons are identical twins, and they are both doctors, which is perfect for this experiment, right? So I post a short video on Blackboard. You can watch that video and then go back to this analysis. So this is a BBC Horizon program, sugar versus head, right? So they have two identical twin doctors, Zand and Chris. So Zand will be on extreme low sugar, low carb diets, while Chris will on extreme low fat diets for months. And then they will compare a set of results to see which one is actually healthier. Right? So here's the setting. So Zand, low carb, Chris, low fat, after months to see which one actually performed better in terms of outcome measures. So let's look at the left column. This is Zand's outcome, right? So remember, Zand relied on low sugar, low carb diet, while Chris on low fat diet. So this basically means he ate meat for breakfast, lunch, and dinner, things like that, right? So mental agility is low, feel sleepy, lost the tracks, all right? And the physical performance flagged, not that strong, and metabolism, though not significant in this, but still have a higher insulin level, type 2 diabetes, right? So which is amazing, right? So if you rely on low sugar or low carb diet and rely that too much, you probably are going to have type 2 diabetes. Oh, but in terms of weight off, you probably have mixed news, all right? The good news is you lost more weight, 3.5 kg. So that's probably the good news. However, the bad news is simultaneously you lost 2 kilograms of muscle as well. Now let's look at the right side. That's Chris' outcome. Rely on low-fat diets, right? So mental agility, high, made money on the stock market, all right? And the physical performance, strong, and metabolism, so this is no significant. But remember this, if you rely on low sugar, low carb diet, you're probably going to have type 2 diabetes. Weight off, of course, weight, that's less, all right? So then they lost more and Chris lost less. So what's the lesson from this? Right? So we probably should avoid foods which present sugar and fat in equal proportion. That's definitely toxic. All right. But if you wanted to stay awake, active, and smart, especially before the midterm and the final exams, right? So you probably want to go for a higher sugar or carb, but low fat diet, right? So that's probably something we can learn from this experiment, because they are identical twins. Other than have different diets, they are identical. Right, everything the same. Even their profession the same, which means they probably live in a very close lifestyle. Right, they are both doctors. All right. So to summarize this is before the test, before any tests, right? It's probably a good idea to have a bite of chocolate. Then it will make you smart, at least for a while. All right, that will be all for this.